Today we've released the version 4.2.0 of the SkyCiv Load Generator. In this video, I will show you all the updates that have been made. First update is the introduction of ASCE 1170.4 Seismic Load Calculation, which is the 2018 edition. So on the load generator, select ASCE 1170, click Site Data, select Australia, select the design working life, and the importance level. Let's say the location is in Perth, Western Australia. It will give you the hazard factor Z and the probability factor KP. You can also view the basis of this by clicking the View Map Data, View Map Contours, and Seismic. Select Western Australia, and you can see the hazard factor or the basis of the hazard factor. So definitely you will need to double check the Z value that is calculated from our server versus to the reference guide that is in the code. And after that, just confirm site data, select the structure data for buildings only actually, and then let's put some data here, confirm structure data. And on this side you can see the seismic load option. Let's check the seismic load option, and same with the NZS 1170.5. You can just select the site subsoil class, and then these input parameters: the largest translational period of the structure, ductility factor, performance factor, and the KTX. This is used in calculating the natural period of the structure based on the formula as stated in the code. Because in the code, you have this minimum value of the base shear, seismic base shear, based on a calculated approximate value of this period of the structure. So, and then let's say we put some dummy data here for the site floor weights. Let's say this is 700 kilonewtons and 600 kilonewtons. Confirm seismic parameters, and then I'm already okay. Click calculate loads, and it will return you the seismic design base shear, which is 430.56 kilonewtons, and the distributed load for X and Y based on the floor weights. After that, the seismic response spectrum for X and for the Y. So after this one, you can check, or you can double check it by clicking the detailed seismic load calculation, and then checking all the assumptions and the parameters that were used in the calculation. So seismic load for X direction and seismic load for Z direction. In this way, you can double check and counter check the accurate values of the seismic base shear. Next is the ASCE 722. We have enabled the snow and seismic load calculation. Definitely this is still in beta, so you can already test that. Just select ASCE 722, select the risk category, select the site class, and let's say it's in Minnesota, USA. So once you put the data or the address, it will generate, or it will give you the snow load, ground snow load, and the winter wind parameter, which is based on the ASCE 7 hazard tool, and also the seismic parameters, which are TL, SDS, SD1, S1, and T0, which you will use on the seismic load calculation. For this one, uh, if if there is no data, you can still use the seismic and the snow load calculation. Just put the data, necessary data here for the site data and the snow load data, winter wind parameter, and you can still use the seismic and snow load calculations. And then select structure data, select building, roof profile. Let's say this data, dummy data, on the snow load and seismic load. So click snow load. Let's say it's terrain category C, fully exposed, thermal condition, and thermal resistance. In ASCE 722, they changed they updated the value of the thermal factor. So they updated it. If it's not, or if you are using all other structures, you need to specify the thermal resistance of the roof. So this is somehow the most conservative, or it will give you the most conservative value for CT, which is equal to 1.2. Just take note of the unit that is being used here, and select slippery roof, and then unbalance. So in unbalance, they updated their drift on lower roof, which is this one. Let's say 7734, and actually it's still the same with the symmetric, and confirm. For the seismic parameters, you just same with the ASCE 716. Just need to select the structure system. Let's say it's concrete, and then based on the height, it will automatically generate you the approximate fundamental period of the structure. Or you can just put something like point 0.4 4 seconds, and then response modification factor. So by default it's equal to 3.5, but you can adjust it. Maybe it's 8. Redundancy factor, let's say it's 1, and then say the seismic weight is around 400 kips. Confirm, and then all or everything is ready. Just click calculate loads, and there you have it. You can see the snow and seismic load results here on the results tab, and then you can click the detailed snow calculation so that you can check all the assumptions that were used in this calculation, also in the seismic load. Right now it's just using 2 point or 2 period design response spectrum. So in the future, or in the next few days or coming weeks, I'll be adding the multi-period response spectrum, and also the MCER values. So this one is in beta right now, so you can just check, and if there's an error or feedback, please let us know. Third update is we added the NBCC 2015 seismic load, which by selecting the NBCC 2015, you can just select the structure, recurrence interval, limit state, importance category. You need to select the seismic site class. Let's say it's stiff soil, and put the location in Canada. So with that, this is based on, or it will give you the data, the nearest data from the Appendix C of the NBCC 2015. So if you need to clarify, or if you need to check the data points, you can just click the view map data, then view map contour, and click seismic. Canada 2015 seismic data points. It will load you all the data points near that location. So, for example, this is Calgary. You already have the base data, and the next nearest Canmore, Alberta, Turner Valley, Drumheller, and Wimborne. So yeah, this is how you adjust it, or you if you want to adjust or use other data, which is appropriate to your location. Definitely, you can just use the map data viewer. After that, just confirm if you're satisfied with this data. Confirm site data, and then select building. Put some dimensions and select seismic load. Check that seismic load. In the seismic load, you need to select the structure system, which is to calculate the approximate fundamental period of the structure. So you can override this if you have specific, or if you have a more accurate calculation based on your model. And then the RD and RO. So overstrength related force, modification factor, and ductility force factor. And then just define the floor weights. Let's say it's 6 meters, 12 meters, and 600 kilonewtons, 600 kilonewtons. And then after that, I confirm the seismic parameters. I'll click calculate loads. And I can get the data or the seismic response spectrum, and also the base shear based on the calculated base shear using equivalent static force. To double check, you just need to click the detailed seismic calculation to check all the assumptions, and then all the data and the formula used in the calculation will be shown here. Just note this is not log scale, so I'll be fixing this one in the coming days.